Hello and welcome to Cloud Insiders, a podcast that brings cloud down to earth. Hello and welcome to Cloud Insiders. Today we're talking about public key infrastructure, or PKI for short. We'll be finding out what they are, what they do, and tips on how to use them more efficiently. I'm your host, Stuart Robinson, and today I'm joined by Matthew Tupper, Senior Consultant at Xtravirt. Hello there, Mr. Tupper.
Hello there.
So, Matt, what are public key infrastructures and what do they do for us? So,
it's interesting, as you open this podcast conversation, you used one of those things that whenever I'm talking about this, I like to have a little klaxon that goes off in my head every time somebody uses what they call an initialism or an acronym, and you use the PKI. Now, this technology, the public key infrastructure, is littered with these initialisms and acronyms, and they are, some of them are just absurd, but this is one of those things where this is one of those technologies where we come across loads of them. So what we're going to do, if I do talk about them and I mention them, I'll try and expand on them where possible.
Thank you very much.
But PKI, or public key infrastructure, it's the layer of asymmetric cryptography that goes across when computers exchange data. So effectively, what you're doing is you're signing something with a public key that can be decrypted with a private key. Now, the actual mechanics underneath this are pretty impressive. It's all based on factorization of prime numbers. So it gets pretty mathematical and pretty deep very, very quickly. So we're just going to sort of stay on the top of it. But what it is for me is it's about assurance. Now, it's a layer of security. It's fairly straightforward to achieve the security of communication, the encryption between two machines. That being that certainly if you're an organic user of that service, you can go to an HTTPS website, effectively a GUI, and your browser will throw an error if you don't trust that encryption source. So you've seen it in Chrome, you've seen it in Firefox or IE. It'll throw a browser, and you can basically click the exception to carry on. Say no, the user is key, or the user as God privileges. I'm going to accept the security mitigations and proceed to the site. Well, that's all well and good. Machines don't do this. You can't do this, and largely in a user environment, I would urge you that that's really poor practice, and we'll come to that later in a second. But what PKI is for me is assurance. It's when you go to a resource, there is a third party or a certificate authority, so CA is what we'll call that as well. That's got a certificate authority that says the resource that you're accessing is definitely or is a very, very high probability that there's a third party that signed up and said this is the right resource. So when you type in HTTPS into google.com or likewise, that certificate that's being issued is definitely from that source. So you're not being spoofed.
Wonderful. You've kind of identified a little bit of computer versus organic issue there, but what problems have you seen clients facing when it comes to public key infrastructure?
The problem is there's several of it. There's the professionalism of it, and this is something that I see a lot when I'm moving around instances. It's all very well, and anybody that uses the VMware web client, most administrators will know what a self-signed certificate is. So you go to resource, it's got a certificate, it's self-signed. It throws the exception. You can choose to install the certificate, so you're accepting its authority. You're accepting the validation of it, or you just proceed with the security risks. So it has a certificate. Yeah. That to me isn't necessarily professional. It's okay inside certain environments, within administration environments where people know that they're accepting, because those people that accept those mitigations generally are skeptical about what they see. So if you're on the internet and something throws an HTTPS error, the first thing I do is close the browser down, just never go back to it again.
Yeah,
I'm ultra skeptical about it. Now, I think it would be ideal in most organizations if that mindset was passed on to the user community, because from a security point of view, the user is the weakest link in the chain, certainly if they have internet access in environments. So they can have spear phishing tactics from various nefarious sources on the internet that are trying to get certain private data and so on out of organizations. So the first thing is, it's all about that. If your organization publishes resources to users where they have to accept these security exceptions, that becomes the standard practice, that becomes the norm. So when a user is presented with something that might be nefarious, it might not be, but the fact is it might be, standard practice is just to click proceed. Oh, I know how to acknowledge these security exceptions, I'll just click proceed. That makes you vulnerable.
Yeah.
So that's the professionalism. Well, the professionalism is, from an admin point of view, you should be affording the CA, the certificate authority, and the validation of those certificates that authority produces to your users. And the users is poor practice in the user community that they shouldn't be accepting, or actually shouldn't be able to accept those security mitigations. So you can put policies in place onto these browsers to say, well, actually, no, as a user, you can't accept these security limitations. If you come across a site that isn't trusted, you're not going there.
Yeah. So how do you enforce this? I mean, how long before browsers or other applications have mandatory enforcement of trusted certificates?
Well, that's right. I mean, I don't think it's going to be long until it's actually already happened. There are certain times when non-organic enforcement, this is where a user cannot accept an override, actually already exists. And a few examples of that would be the Citrix storefront, for instance. I do a fair amount of work with Citrix as well as VMware. So the Citrix storefront, if you're accessing the Citrix storefront with a Linux receiver or the Linux client, there is no security exception for that. You must have HTTPS, or the receiver simply will not connect. On the Windows receiver, you can actually hack that. There's a little registry workaround for that to make that accept a non-trusted certificate. So it will still present you with the resource. But if you're using the Linux clients, the Linux receivers, there's no way around it. You must have the certificate. The other ones are PowerShell. So you might want to sign PowerShell scripts or run PowerShell scripts in your environment. Well, if you don't sign them, by default you can't run them. I mean, what you can do is you could drop the skirts of PowerShell and say, set the execution policy to unrestricted. It's not a good idea. Again, this comes back to this best practice. What you're doing is you're lowering the bar of security to just let poor practice flood across.
Yeah.
And you've got the things I mentioned, the VMware web client. It produces a self-signed certificate. Well, wouldn't it be nice if it didn't? If it just had a proper trusted certificate? And sometimes you need internal certificates. One of the other examples of VMware is if you're using VROPS, vRealize Operations Manager, to talk to vRealize Login Site. If vRealize Login Site and vRealize Operations Manager don't trust each other on a certificate basis because they're not actually linked to a directory. And remember, computers that aren't part of the same directory use certificates to trust each other.
Yeah.
So certainly Linux does this a lot. Just as a side note, if you're using SQL Server 2017 on Linux with something like Pacemaker for a cluster, these machines won't be joined by an Active Directory. They have no way of trusting each other. So the only way these machines will trust each other is certificates, but that's an askew. So that's the same way that vRealize Operations Manager and vRealize Login Site, if you're in the Operations Manager and you go to the login site to look at the logs and the machine doesn't trust it, you'll just get a certificate error. And there is no organic workaround for this. You can't say, okay, I trust that. No, because it's the machines that trust each other. And that's where you need these internal PKIs, so the public key infrastructure. Even though it's internal, it's still public key. It's not private key infrastructure. It's a common misconception that some people call it a private key infrastructure. It's not private. It's public key infrastructure. It just happens to be within your private organization because there's a publicly shared key. And once you've got this public key infrastructure in your organization, it's very easy to cut certificates for these devices, apply them to the devices, and then they'll trust each other.
Brilliant. So you've said about professionalism, poor practice and enforcement. So how should people be going around solving these issues? Are you seeing the same pitfalls? Is everyone falling into them?
Yeah, I mean, what I see mostly is when we come across very large, organized structures. They have security environments where they have their own CAs, and we're able to request certificates for various purposes. And this doesn't always work, because the person making the request doesn't necessarily understand exactly what they want, and sometimes they get, they ask for X and they get Y, and they think, well, that doesn't work, but there's a way to massage that and work with it. And then in some organizations, what you do see is the fact that they don't have a PKI, so they have all these certificate exceptions that they have to request. And in other cases, they go to the internet to buy, it's difficult, they buy certificates from public certificate authorities. Now this is still PKI, it's still public key infrastructure. But what they're doing is they're going to the likes of VeriSign or Thwart or Symantec and saying, I'd like a certificate for this domain. And bear in mind that domain you're asking for, that certificate you're asking for, must be a public resolvable namespace. So that's a top level domain namespace. You can't ask, and you haven't been able to for some time now, what you can't do is you can't ask these public certificate providers for private IP addresses and private namespaces. It must be a publicly resolvable name. Now, if your internal infrastructure that we're talking about can't resolve these IP addresses, let alone communicate with the internet to be able to see that it's the certificate is valid, it will fail. And everybody that's ever used a Microsoft Management Console knows the pain of certificate validation. So this is the and I'm going to use one of those initialisms here, the CRL, the certificate revocation list, so the certificate revocation checking. So when you fire up the Microsoft Management Console of various products, the first thing it does, it takes about 30 to 40 seconds to open. And you as an administrator, you think, well, I don't know what this is. It's just a blankness, and then everything works. What it's doing, it's going to the internet to see if your .NET framework has a valid certificate revocation list, because it's built into the Microsoft products.
Yeah.
So what most people do is go straight away and just disable it. Well, if you issued your internal certificate, you wouldn't necessarily have to do that. But that's what I'm saying about poor practice. We see a lot of this using of top level domains where they can, and then internally where they can't, they just put these workarounds in. The other thing I should say about these top level domains is they're not cheap. Some of these certificates that people issue, the cost of managing these over the lifetime of managing, if you have many of these publicly issued certificates, can be exorbitant. I've recently working with an organization where you had to buy a certain amount of credits to have a certificate issued, and it was multiplied by every time you wanted to make an option. So you had to say you needed 1 credit for the machine you wanted to issue it to, you needed times the number of years that you want the certificate for, times the number of SANs. Now that klaxon just went off in my head, I just said SAN. So the subject alternate name. This is the other names that the certificate can have. This is what I mean about the initialisms. That's an acronym, isn't it, SAN? So yeah. The acronyms in these certificates. So the subject alternate name, I'll digress very quickly, is the other names that the certificate has. So if you had a resource that you were accessing saying mywebserver.mydomain.local, that's the FQDN. You could have my web server just in the SAN. So if somebody types in https my web server, hits enter on their browser, it would still resolve that as a certificate, because that's a valid name. You can even put the IP address in there. That's what I mean by the SAN, the subject alternate name. So all certificates have a CN. Now again, that klaxon just went off. A common name, which by the way isn't trusted by Chrome since version 33, so you must have a SAN in your certificate.
Yep. So
again, it gets very complicated. It's a moving feast. So Google deprecated the use of common names in fairly recent history, a couple of years ago, I think it was. Maybe it was last year, I'm not sure. But it was fairly recently that they deprecate the use of CN, so you must have SANs in your name. So this makes it tricky that you've got to inject all that. So just to go back to this.
Can I klaxon you on FQDN?
Oh, sorry, you can, of course, yeah. So fully qualified domain name. So that will be, obviously, well done. The the fully qualified domain name. So if you imagine you have your short name or your host name, which would be my web server, and the FQDN would be the suffix part of that. So my web server dot my domain dot local or whatever it would be. So yeah, the FQDN of Microsoft is Microsoft.com or something like that. If you went to the HTTPS site.
Beautiful.
So yeah, thank you. But yeah, this is what I mean. It's full of these things, and I've got a table of these things because sometimes even I forget. Sometimes I'm coming across the documents, I'm going, I can't remember what that one is. So every time I come across one, I make a table. I throw it at the top of a document. I don't know. It helps me as well.
Yeah, I mean, it seems to be its own little micro environment of acronyms as well, because SAN to me is just storage area network.
Yeah, exactly right, and they're all interchangeable. Yeah, you can go to acronym, the acronym finder on the website and put it in the IT, and then most acronyms have multiple purposes. So you've got to find some sort of context as to what you're addressing. So back to the cost of these certificates. If you say I'm going to issue this certificate, one credit. Let's say a credit costs $100. One credit costs $100. That's the server. Then I want it for 5 years, which is a reasonable length time where you want a certificate, because you don't want to be replacing these certificates very frequently.
Yeah.
It depends on the security the security profile you want to apply to it. So 5 years is the certificate, so that's going to cost you $500 now. 1 times 5, $500.
Mm-hmm.
Then you say, and then I need maybe 5 SANs. Oh, so 1 times 5 times 5. That's just cost
a lot of money.
That's just cost $2,500 for one certificate.
Yeah.
And then you might say, oh, well, I've got a whole load of load balancers that I need to apply. I've got 6 of these. The cost runs away, and then every 5 years you have to cut another one.
Yeah.
I mean, it might be the fact that there's a management overhead as well. There's a sweet spot you've got to find about the length of a certificate, how long. Because see, my envisagement is that internal public key infrastructure would be as ubiquitous as Active Directory and Microsoft Active Directory in environments, in the fact that they actually do go hand in hand. They fit very much hand in glove. They fit very easily together, because Microsoft have got quite a good product for this. The Active Directory Certificate Services feature and server roles is a very good starting point. But to me, the two should go together, because they're layers of security. One is a checkpoint security, in as much as it asks you for a username and password, and the other one's all about assurance as to are you contacting, like for instance the LDAP S security that you might want to have against your Active Directory controllers and things like that. Yeah. So you've got to find a balance between the issuing of the security. So unlike Active Directory, any PKI infrastructure that you install has an inbuilt time bomb. It will expire. Now there's various levels of expiry. The certificate will expire. Well, that's okay. I can recut another certificate. But eventually, the actually whole infrastructure will expire. So right. What you have to do is you have to plan quite far into the future.
Okay. So it's far easier and faster to cut or renew certificates if the PK is owned.
Yeah, indeed. I mean, it takes us back to this, what I was saying about the cost of public certificates. If certificates cost X, Y, and Z, and you're spinning up even a test environment, you've got the cost of obtaining those certificates. Whereas if your PKI is owned and utilized in-house, it's far easier just to create as many certificates as you require and as expediently as you require. With any sort of time frame you want. It's not impossible to say, I don't know how long this is going to last. I'll create X year certificates. In fact, in the environment that I've just stood up for a customer of ours, we created 10 and 11 year certificates, because we knew that the solution we're deploying had a usable life of 10 years, and there was going to be some light touch administration on it. So the deploying certificates where it was necessary to deploy, it wasn't the fact that we wanted to, we absolutely had to, because we had this non-organic transmission of data between devices, so we had to do it. So what we were doing was we created certificate templates in our own public key infrastructure. But the templates all lasted for 10 years, so we know that the life of this platform, those certificates will be valid and nobody has to go in and renew them. That's not to say that all of them are like that. There's some that have got 2 and 3 year certificates that what we do is we flag those in a calendar, and we make sure we get onto those at least sort of 8 to 6 weeks before they expire.
Brilliant. So have you got like 2 or 3 pieces of advice to help people solve the problem more efficiently?
Yeah. So the first one is it's all about literally what I spoke about the length of the certificate. So find some pragmatism between security and usability.
Yeah.
So what you do is you plan from the leaf object up. So the leaf object, that being the certificate that gets issued to the endpoint or the user. So how long do you want that to last for until you manually have to renew it, or until it auto re-enrolls? And that's another subject for another time. But it's possible to have devices and users auto re-enroll certificates. So if you said that was 10 years or 5 years, what you generally do is you make the upstream certificate authority, the rule of thumb is double that. So if you've got a certificate that you know lasts for 6 years or 5 years, I always add a bit of fat on there anyway. So if it's 5 years, make it 6 years. Double the upstream certificate authority life. So that means the certificate authority, the part of the infrastructure that issues the certificate, double that. So that will have a life of 12 years. Now that might be what we call an intermediate certificate authority. So that might have a parent. So that certificate authority's parent would have a shelf life of 24 years. So 6, 12, 24, and then what we might have is that might be a child of another parent authority. So that parent authority then gets a certificate authority of 48 years. To be honest, that's not practical. That's just they're in the realms of absurdity. 48 years, it really is crazy. So that what I generally do is I truncate those doubling of those years to maybe a third. So you go 6, 12, 18, 24, that sort of thing, because that's reasonable. And there's those people out there. You come across environments and think, well, I'll probably not have this environment for 6, 10 years, 10 years probably max. Well, you say that, and we come across a lot of environments where we come across Windows Server 2003, or in some cases we come across NT4, and you think, well, to think that you might actually get rid of this solution in 10 years, that might be optimistic. If you're still running Server 2008, chances are that's coming up to 10 years old, right? And maybe not R2, but so I generally plan for infrastructures to exist for about 10 to 12 years, and then I think that once they've got to that length, if something goes wrong with the certificates and nobody's managed it in that time, then poor planning. So, the other thing is, I would say, and this comes down to what I was talking about, the child and the leaf object, and this is about tiering of certificate authorities. It can be very easy and very straightforward, and it's good. If you're just trying it out, it's in a test environment. There's no reason not to do this, but you can simply pull up a Windows server, install the Active Directory certificate services role, and have a single root certificate authority, one root that issues certificates. In reality, that's terrible practice. Don't do it. Have some tiers. So have a root certificate authority. Best practice for security is to have that offline, so it's not connected to anything. Then have an intermediate certificate authority that issues certificates, or maybe it doesn't. And then you can have, so that would be a 2-tier. So you have your root certificate and your intermediate. My preference is to have what I call the wedding cake analogy. So if you're at a wedding and you see the cake, well, if it's a single tier cake, it's a pretty poor cake, isn't it? 2 tiers are good, 3 tiers are always best. So that's the way I look at it. You want your offline route, you want your policy CA. This is the intermediate policy CA that generates other certificate authorities, such as so the policy CA would issue a certificate to a VMware certificate authority, so a VMCA in the platform service controller, such that that could then issue leaf certificates to all of the objects within vCenter, and then you'd have other issuing CAs for various objects throughout the enterprise. So my third piece of advice would be documentation. It's the CA. It's not an easily researched subject. It's not as prescriptive as Active Directory roles, X500 roles, and other security roles like antivirus. There's not a single vendor, or there isn't a vendor that's going to give you a very narrow, constrained solution. The solution is very bespoke to each client. Like I was saying about the tiers, right? You can do it. You can sort of bake it any way you want. A bit like domain forest in Active Directory, right? If you don't document what you're doing, you're going to get lost very quickly. And that's what I say. So always document that.
Yeah.
And the fourth piece of advice is, if you are using a Microsoft PKI, so public key infrastructure, the Active Directory certificate services, don't accept the default templates. I mean, use them if you want, they're okay for auto enrollment, things like that, but do create custom templates. I've done this quite a lot. I've done this, and this is what I was saying about creating 10-year certificates. So where you need a certificate for 10 years, the default templates aren't going to work. They're all for 2 years. So the last thing you want to do is every sort of 20 months, because you want to be doing it before, or 22 and a half months, sort of 6 weeks before the certificate expires. You don't want to be going to there, creating a new certificate, going through the change process of issuing new certificates. Unless you absolutely have to, unless that's a security requirement in your organization, then you've got to wear that hat. But if you don't have to do it, create templates that last for longer. Create 5, 6, 10, even longer certificate templates for your servers, such that that certificate will last for the duration of that piece of infrastructure. That's what I would say. Brilliant.
Well, I think that pretty much covers off everything we had. Have you got any final thoughts you'd like to give us?
Yeah, I mean, why not get Xtravirt to come and do it for you? Yeah, we do this a lot. It's certainly something that we're seeing an uptake in, where we're going into organisations, deploying the PKI. What we can do as well, it's all about is coming on site, designing the solution for you, with your policy, with your administration scope, with the level of knowledge that the people that are in that organisation have. Going through the necessary upskilling process with them, or the knowledge transfer. Then we can either sit with you and build the environment out. That's what we prefer. Such that then that gets that knowledge transfer more ingrained with the people on the ground. And then moving forwards, what Xtravirt hope to do is be able to manage those certificates for you as a layer. So where we cut certificates, we'll take those calendar reminders away, and we'll put them in there, and we'll be contacting you. So the thing with certificates is, you generally find is if they have a protracted life, if a certificate has a life of 6, 8, 9 years, you could put a calendar appointment into the collaborative software of all the people that were part of that project. Say, okay, we've got to renew this certificate in 8 years and 10 months. Well, in 8 years and 10 months, that calendar appointment may go nowhere. It may just be legacy, because none of the people that are part of that project work there anymore. Yeah. So that's what we're looking at doing, is providing us a wrapper for that layer, such that we'll be proactive about this. We'll let you know when you've got certificates that expire, even if they're internal ones. So
thank you very much, Mr. Tupper. Thank you very much for your time, and we shall speak to you soon.
Yeah, great. Thanks a lot.
Thank you for listening to this episode of Cloud Insiders. To find out more and to listen to additional episodes, go to cloudinsiders.fm. You can follow us on Twitter @Cloud Insiders and subscribe